we have a truss showing here built from identical 3-meter long pin jointed members. So all the members are 3-meter long. So then we can easily know the degree, the angle showing here is 60 degree. So we need to calculate the member force in BC, CE, and DE, and we apply a force here is 8 kilonewton. Okay, so there's two methods to calculate the member force: method of joint and method of sections. We can combine these two methods in one example as well. But here I'm going to show you how to using method of sections to calculate the member force. So because we want to know the member force in BC, CE, and DE, so we better to cut the structure this way. So cut away this way, and then the structure is showing here. So then we put the member force on the part of the truss. We assume the member force is in tension. So then the member force is in go outwards of this section. We got this is FBC, this is FCE, and this is FED. Okay, we need to know the FBC, FCE, and FED. Okay, so let's go back to the truss structure here. So we know we need to calculate the reaction force here. So here is LA, and here is RD. Okay, we know this the A joint is a pin support, so they definitely have a horizontal force RAX. But horizontally, there's no other force, so RAX must be equal to 0 to satisfy the equation of equilibrium in x direction. So then we find this structure is in symmetric conditions. So the geometry is symmetrical, and force is also symmetrical. So we know the force at point E is 8 kilonewton. By using symmetry principles, we know RA equal to RD equal to 4 kilonewton. So RD is 4 kilonewton over here. So the direction is go up as well. So then we put the reaction force at joint the support A is 4 kilonewton, and joint E is 8 kilonewton. So once we know this force on this part of the truss, then now we can apply the equation of equilibrium to calculate the member force. So first of all, I need to apply the moment equation of equilibrium at joint E, because we find FCE and FED are go through one point. This is joint E. So if we calculate the moment at joint E, so we don't need to consider FCE and FED because they go through this joint. The moment is 0. So then we only have one unknown force, that is FBC. So that is the reason we just write down what we come out moment equation of equilibrium of joint E. So I'm writing here. So we write down the moment equation of equilibrium at joint E. If we assume the positive direction for this equation is go clockwise. So first of all, we have 4 kilonewton reaction force, have bending moment at joint E, that is go to clockwise, so that is positive 4 kilonewton times the lever arm is AE. So AE is 3 meter times 3. So second, we find FBC have a bending moment at the joint E, so and it's go to clockwise, so it's positive FBC. Then we need to calculate the lever arm. So the lever arm showing here. So this is a lever arm. This is a lever arm, and we see this is H. Okay, we need to calculate the EH. This is lever arm of FBC. How to calculate EH? So we know BE is 3 meter, and the BH is 1.5 meter, because we know all this degree 60, all these angles are 60 degree, and so BE and also EC, so EC is over here, C is equal to, so BE is 3 meter, EC is 3 meter, BC is 3 meter, so VH is going to the midpoint of BC. So if we look at here, so this is also lever arm. If we say this is G, BG is at the midpoint of AE, so it's 1.5 meter. Okay, so same idea. So it's here, BH is 1.5 meter. Then EH, so times EH equals 0. And we know EH can be calculated equal to square root 3 meter square minus 1.5 meter square. We can calculate the result is approximately equal to 2.598 meter. Okay, so then FBC is equal to negative 4 times 3 over EH, and EH is showing here, so then we got the result. VH is 2.598 and equal to, we're using calculator, we can come out to the result is negative 4.62 kilonewton. So the FBC is negative. That is mean our we assume directions go to red, or the tension force here FBC is not correct. So oppositely, because it's negative, the oppositely FBC should be compressive force. So FBC is compressive force. So we join over here. So the direction over here, the value is 4.62 kilonewton. So we got FBC. Then we're using the other two equation of equilibrium to come out the FCE and FED. Okay, first of all, if we write down the equation of equilibrium in y direction, so vertically in y direction, we find in y direction we have 3 force. So first of all is the reaction force 4 kilonewton at the joint A. If we see for this equation, the up is positive, so we have 4 kilonewton positive. The second force is the force at the joint E is going down, so it's negative 8 kilonewton. So the third force is a component of FCE. The component of FCE is shown here. Okay, so if we say this angle, so this angle is, so this here is 60 degree, then this is 30 degree. Okay, so the angle of this force is, it's positive, so it's FCE times cosine 30 degree. Okay, cosine 30 degree equal to 0. Then we have FCE equal to 4 over cosine 30 degree. Then we got results. FCE have a result is 4.62 kilonewton in positive. So that means the direction FCE is going this way, and that means the number CE is in tension. So we got FCE, then we can come out FED. So we just need to write down the equation of equilibrium in x direction. So if we assume for this equation the positive direction is go to the right, so then we have, so then we'll check horizontal force. Horizontal force, we have FBC, so go to left is negative 4.62 kilonewton, and we have FED is positive, and then we have a component of FCE. So this component is go to red is positive, so FCE times cosine 60. So this is component of FCE in horizontal direction and equal to 0. Then we come out FED is equal to 4.62 minus FCE times cosine 60 degree. This is equal to 4.62 minus FCE. We got a value is here 4.62 kilonewton times cosine 60 degrees is 1/2. And we got the final result is 2.31 kilonewton. Okay, so this is intention, and this one is compression. Okay, so look at the question that we need to calculate the member force with 3 significant figures. So our result is satisfy the 3 significant figures. So member force in BC is 4.62, and in compression, the member of CE is in tension. The value of the tensile force is 4.62 kilonewton, and the member ED is in tension, and the value is 2.31 kilonewton. So this is the examples to use method of section to calculate the member force in BC, CE, and ED. Thank you.